Yeah, so I'll exactly talk about Puppet at Spotify. I mean, most of you probably know a bit about what Spotify is, but for those who don't, we're a streaming music service. We're deployed in, or launched in 28 different countries with over 24 million active users, that's monthly active users. It contains over 20 million songs and 1 billion playlists created by users. And this is growing very, very quickly. I mean, both in terms of amount of users, but also in terms of the hardware required to run it all, and also, of course, in amount of employees, where as a company, we're growing very rapidly. So that, of course, poses a lot of challenges, and which some are very interesting and fun to work with, definitely. And I mean, Puppet has been a great help for growing the infrastructure really rapidly. So, a bit about who I am. I'm working as a system engineer in our site reliability engineering team. That is spread out in Stockholm and New York, with most of it in Stockholm, and I'm working from the Stockholm office. I'm also an operational system owner for Puppet at Spotify, but also for our playlist system and our Cassandra clusters that we use quite heavily. And I'm also a community contributor to Puppet. We've been using Puppet since 3 years, probably almost 3.5 years now back. Before that, we used a configuration management system called Phi, fully automated installation. Some of you might know it, I don't know. It's fairly Debian specific and basically made to like provision machines and runs a lot of shell scripts on them to do all the configuration. It's not that great to work with, definitely not. But we gradually switched to Puppet. I hadn't started at Spotify when we did it. I was working at another company with Puppet back then. But it was a gradual change, but since quite a while back, every part is configured by Puppet, and we've since quite a long time ago deprecated Phi entirely. So we provision machines and pretty much only do the base installation, install Puppet on top of that, and let Puppet do the rest. One fairly uncommon thing with our Puppet installation is that we allow the developers to do a lot of the changes, and they're maintaining most of the modules regarding how their systems are deployed, how the applications are deployed. So in our Puppet repository, we have 220 different people that have committed code, which is, there's a lot of, some other companies that have it like that as well. But, for a lot of companies, probably only the operations teams is the one that are committing code in Puppet, but that's not the case here. We do push out a lot of changes. We have around 450 changes, like non-merge commits per month, which is also, they're merged and pushed out immediately when they're merged. So, because we're up 24/7, we don't have any weekly maintenance downtimes or anything like that. So when a merge is committed and merged, when a commit is merged, it's pushed out immediately to all the servers. It's 325 different Puppet modules in our repository. At the moment, that is one big repository with all the Puppet modules. We're using Gerrit at the moment for code review. So anyone can submit review requests to that, but to merge them into the production branch, they have to be reviewed by the SRE team. yeah, so a little bit about more about the Puppet infrastructure and so on. We run roughly, or manage roughly 5,500 nodes using Puppet. That's across 3 different Puppet installations. So there's one installation for the production environment, one installation for the testing environment. They share the same Puppet code base, so it's the same manifests between them to configure the machines, but they have different CA authorities and different PuppetDB instances. There's also one Puppet installation for the desktops and laptops, called IT Puppet. That's managed by our IT team. It handles all the configuration across a lot of Mac and Windows laptops and desktops. Stuff like, all kinds of stuff like printer settings and network authorization policies and that sort of stuff. That also has that one has its own code base though, and also its own CA authority and PuppetDB instance. We have at least one Puppet master per data center. Most of them have more than one. In total, there's actually 16 Puppet masters at the moment. So they have roughly 600-700 agents running on each one of them. We run Puppet using cron, so we don't use we don't have a constantly running agent. It's run using cron once per 30 minutes, so the default there, but it's splayed out, so they will run on different minutes and seconds. It's a small wrapper script, actually, that does the seconds part, as cron only does minutes. And I could mention here that some little bit special settings we use for the Puppet masters are that we only do one compilation per worker process, which of course increases the load a little bit, but we've found that there's some parts of the Puppet master that doesn't really handle isolation that well, both across environments, but also even when you update the code in one environment. And that's not with manifests, that's handled very well, but with stuff like custom functions and custom types. So for that reason, we just do one compilation per worker process. For any other requests to the Puppet masters, they can handle thousands of requests for a single worker process, but as soon as a compilation request comes in, we just allow one. We also have a caching of the file metadata requests. Some of you might not know it, but I mean, if you have a file resource in Puppet with a source attribute, then the contents of that file will not be part of the catalog that's shipped to the agent. And the agent, when it executes the catalog, it will contact the Puppet master again and ask it for the checksum of that file resource, and then compare that to the one on disk. And if they differ, it will again request the file contents. So it's fairly chatty if you have a lot of source attributes or parameters on your file resources. So, and I mean, under the default settings, each one of those goes to a Ruby process and down the whole stack. So we use a 5-minute caching using mod memcache in Apache. So most of those are handled just by the Apache layer. That decreases loads quite significantly on the Puppet masters. On the other hand, it might take a little bit longer before your updates go out, of course. We're using we have it mapped so that one Git branch equals a Puppet environment. There's all the nodes normally run against the production environment, which corresponds to the production branch in the Git repository. But otherwise, anyone can create feature branches and commit and push to them. They are checked out on the Puppet masters as to different directories and mapped to different Puppet environments. So on any node, you can run the Puppet environment or the Puppet agent against any Git branch and test out your changes before you merge them into the production branch. And that's very, very useful, definitely. So we don't have any static environments apart from production. There's no like testing or development environment in Puppet. They all run against the same code base. And as I mentioned earlier, to get it into the production branch, you have to do a code review. For backend services, I mean, we're a Debian shop. We run Debian across all our servers. So all our internally built services are built as Debian packages. So they're distributed using regular apt repositories and all the built-in tools. And of course, then deployed using Puppet, I mean, using package resources in Puppet. So they're no different than the system stuff. And I think that's a very good method. It simplifies a lot of things. There's no different method of upgrading your applications than it is from upgrading the rest of the system. You don't have to do like 2 different things to upgrade each part of it. I caught a cold, so my voice is a little bit off. With our backend services, I mean, this is a kind of simplified diagram of how our infrastructure looks like. But when a client connects, it connects to an access point, which basically works as a proxy, and that one will authenticate your client, and so on. And once you're authenticated, the client can send commands and requests to the different backend services, and they're all proxied through the access point then. And the access point will find a backend service host to send the request to, and it will also do some tracking of the state, like health checking and that sort of stuff of different hosts. And then send them to one of them. Some backend services themselves also contact other backend services, of course. We try to separate as much as possible the responsibilities of different backend services. So usually one kind of system or part of the Spotify service consists of multiple different daemons running on different hosts. And most of those are stateless, of course. So we can expand them out and easily. And for the storing the states, then we prefer to use Cassandra, which is this NoSQL database that you can deploy in clusters and scale out pretty much indefinitely. For some of the stuff, we use Postgres, though, and also Tokyo Cabinet for some indexes. For example, like search indexes or things like that, they are actually distributed to the service machines and sit there on disk on them instead of using like a database or something like that. This is, of course, a bit simplified. I mean, sometimes we don't have every service deployed in every different site, so sometimes the access point can actually contact a service machine in some other sites, or backend services can contact other backend services in other data centers and that sort of stuff. Most of them are deployed in more than one site at least, but maybe not in every site. And a lot of them are implemented using Java or Python. So when we deploy a new backend service, we create a Puppet module for it. Or the developers that created the service create a Puppet module for it. That's then deployed and tested in our testing environment. It's virtual machines, but they work pretty much the same as the production environment. And then when they're happy with it and want to deploy it live, they request hardware from our SRE team. We provision some hardware for them and tag them with that Puppet class that they've created. And then it's hopefully live after that and works perfectly. For service discovery, like how the different backend services discover each other and how the access point discovers like which backend server it should talk to, we use SRV records, which is this DNS record that just supports like pointing out host names, also the weight and priority. And as we use this for almost all our backend services, we use it for Puppet itself as well. So the Puppet agents find out which Puppet master they should talk to using SRV records. And they point to the one in their site, or the ones in their site, and have like a weight between them. So it's load balanced between those Puppet masters. But in some cases, they can also fall back to Puppet masters in other sites. I've also written a Puppet module called DNS query, so you can actually query DNS records, like all kinds of DNS records, but of course also SRV records directly in your Puppet manifests. We've noticed that there's some services that don't support SRV records, and in some places we need to embed the IP addresses or host names like in config files. So then we can query the SRV records in the Puppet manifests and then just put that templated out in the config file. For node classification, at the moment we use different external node classifiers in every different Puppet installation we have, which is not an ideal situation. We're planning there on switching to using Hiera for node classification as well. So we've set a host name standard that has like it contains which site the machine is in, it contains the role of the machine, and also like different pools and different pool IDs for if you have slightly different configurations on different types of the same role. And each of these parts are exposed as custom facts in Puppet, and they're also parts of the Hiera hierarchy. So with this class tagging, you can classify nodes based on their role, for example. So you just say that this role should have these Puppet classes, and all of the machines will get it. So you don't have to do it like individually for each node or anything like that, as we have to do at the moment. We haven't yet migrated all our hosts to this new host name standard. Actually, we used to have female names on all our servers up until we had around 1,500, 2,000 servers. And we pretty much ran out of names. So that wasn't a very good naming standard. I don't recommend you to stick to with that naming standard to that number of hosts. They got really, really weird, the names at the end. I'm gonna talk a bit about some contributions we've done to Puppet and the various Puppet-related projects that we've published. I mean, in the last 12 months, we've got 25 different pull requests merged to Puppet and Factor core upstream. It's a mix of bug fixes and new features and optimizations. Some small, some a little bit bigger. So that I think that's good that it makes it available for everyone to use. We haven't published that many modules yet. We've also gotten some fixes to some upstream modules merged, but hopefully we're going to be able to publish more modules in the coming year. We've also created a system to more easily query the data in PuppetDB. As we have PuppetDB in every Puppet installation, there's a lot of useful data in it that we can query. And I mean, we have a lot of custom facts and that sort of stuff. But to write PuppetDB queries, they look something like this. It's quite complicated for people to write them. It's quite complicated to understand what this query does. So I wrote a sort of small compiler that compiles a simpler query language to the actual PuppetDB query API. So that query that was on the last slide, that's actually the top query here. It asks for nodes that have the Cassandra class version 1.1 and are in the site London. So it's a quite simple query, but it's still very complicated in the API. This one does like operator precedence, so you can have and or, parentheses, that sort of stuff. You can query for more than, less than, equals, regex matching, all that kind of stuff that the PuppetDB API supports. It's called the dalen-PuppetDbquery. It's available as a Ruby gem or as a Puppet module on the Puppet Forge. It contains both a Puppet face, so you can query on the command line like this. It also contains query functions, so you can query directly in your Puppet manifests. And we found that to be simpler than using like exported resources in some cases. Like, I mean, sometimes you just want a list of hosts in a config file, then it might be simpler to do a query like this and store it in a variable and then like loop over that variable in an ERB template instead of like exporting concat fragments with one line each and realizing them on the other side and that sort of stuff. It also contains a Hira backend, so you can, instead of writing out list of hosts in your Hira configs, you can write out a PuppetDB query, and it will execute that query and return a list of hosts there. Also made a Datamapper adapter for PuppetDB. Datamapper is a Ruby object relational mapper. So with this, you can treat PuppetDB resources as Ruby objects and query them using this object relational mapper. I mean, this will print out the facts for a node, but it supports a lot more complex queries than that. Excuse me. It's not fully optimized for all the queries. On some subqueries, it actually executes 2 queries to PuppetDB, but it works. Feel free to use it and contribute back patches. We made a small utility called PuppetLS. Might be useful for some people. So you can, on an agent node, you can do a PuppetLS and some directory, and it will list file resources that are managed by Puppet in that directory, and which file manages them, which line, where the content came from, if it's a file parameter or a content parameter. That inspects the catalog that the Puppet agent stores on disks and just kind of finds out file resources from that. It's a little bit scary, though, because sometimes people think that, oh, if it's not managed by Puppet, then it's OK to edit those files by hand. That's not the intent of this. So a little bit about the future. What are stuff we're planning to do in the near future? Well, at the moment, as I mentioned, we have one big repository that contains all the Puppet modules that we're using. We found that to be, I mean, it's a very simple workflow when you want to make changes, etc. But it's a little bit unflexible. We would like to move more like module ownerships out to the squads that actually manages or develops that service. And when they're in one big repo, that becomes a little bit tricky, also with the ACLs on the repo, etc. And so we would like to remove the requirements that the SRE team reviews all the commits and let developers review the commits for their modules. We would also like to support testing using Vagrant a bit better. At the moment, we have some assumptions in our repository or manifests that you're either in the production environment or you're in the testing environment. And it tries to contact the different inventories, databases based on that, and do some find out some data about the node. And that, of course, it doesn't work when you're running masterless on a Vagrant machine. But that should probably be quite easy to fix. We're also looking into using containers and deploying container images with services, with the entire stack, with libraries and everything to have a tested stack with all the libraries and stuff, instead of hoping that all the libraries on the machines are exactly the same across all the nodes in a cluster. So we're probably going to use Puppet Apply to build them out, and we would like to support that a little bit better. So in order to do this, we've started on a new workflow for our Puppet manifests and modules. And we've called that SpyCore, that project, which is this nice human figure as well. Most of our internal projects start with SP. So that consists of a node terminus and a Puppet Forge implementation. It's not a proper node terminus. It's not a real node terminus that actually classifies your nodes. It just calls another node terminus to actually do the classification. So you can use this with an existing external node classifier. But when an agent requests a catalog, it will do a checkout of our Puppet repository, the branch that the agent requested. And then it will do a Hira lookup in that repository to see what modules should this node have. It also supports getting that information from the node terminus itself, like the ENC can supply a parameter with the modules that should be installed on that node. And then it will use the Puppet module tool to install the module specified, and optionally you can specify versions that it should install. And typically each node would only install our base module that's installed on every host and the service-specific module. And then those would contain all the dependencies on any other modules they would need. And as it uses the Puppet module tool to install them, all those dependencies will be resolved automatically or by the module tool. That, of course, it slows down the Puppet runs a little bit. We found it to be fairly fast. Of course, requesting and installing the Puppet modules from the Forge would be quite slow for us. With this many nodes and Puppet runs, that would mean installing 50 modules per second or something like that. And I'm sure the Puppet Labs operations people wouldn't be too happy about that. So we've created an implementation of the Puppet Forge that we can use. It's a quite simple implementation. It only supports the API part to install modules. There's no web UI or user management or anything like that. It just contains the modules, and you can request them and install them. But one feature that it has that's special is to support our kind of existing workflow where we can have Git feature branches, and they map to Puppet environments. It supports multiple environments in this Forge. So when you're creating a feature branch of a module, you can do some changes, build it on that feature branch. Our build system will build the module, upload it to that environment on the Forge. And when the node, or actually the master, is installing the modules, it will try to install it from the environment that the node requested, so the same environment on the Forge. If it can't find a module in the environment that was requested, it will fall back to the production environment. So you don't need to have every module installed in every, or available in every environment on the Forge. You only need to have the one you're actually developing on. So that will also allow us to, for a lot of use cases now, we kind of abuse this mapping of Puppet environments to Git branches to do some different things. Sometimes it's for developing new features and testing them out, kind of like feature branches, but sometimes we also use it for gradual rollouts, canary clusters or hosts, and that sort of stuff, when we want a slightly different config or newer code on one of them. And this will allow us to much more easily only deviate one of the modules, but keep all the rest of them in sync with the rest of the environment. We looked a little bit at the other tools available, like R10K and Librarian Puppet. Unfortunately, we found that, they assume that you have in an environment, they assume that you have the same versions of every module across all your hosts. It's kind of linked to that environment. This, as I said, builds a new and a node-specific environment on demand. So different nodes can have conflicting versions of modules. And as we want to push out more and more responsibility for maintaining the modules to different teams, we needed to allow them to work independently on their modules. And we need them to be able to make backwards incompatible changes without requiring every other user of that module to modify their modules to suit these backwards incompatible changes immediately. And as the Puppet module tool has semantically versioned modules, and you can have dependencies using Semver, that makes it very easy for us to support that kind of workflow. So, one module can have the Postgres, or one host can use the Postgres module version 1 dot something, and another host can use version 2 dot something. You can even have Spotify Apache on one of your hosts, while you have Puppet Labs Apache on another host. And that's also something that we would like to do, to switch to using a lot more upstream modules. But we found it very tricky to do at the moment, because if we want to switch out our existing Apache module to the Puppet Labs Apache, we need to change every other module that uses the Apache module to use the Puppet Labs one as kind of a big bang change. With this, it should be possible for us to switch different services to use other modules gradually. And hopefully that will allow us to use more upstream modules and also write more flexible modules of our own and publish them upstream. And this will be, we've coded the code, made the code, but I haven't written much documentation yet. So I'll try to write some documentation for it before open sourcing it, but that should be done very soon now. So that's it. I'll open up for questions. I think there's a mic over there. Maybe it's best if you come to the mic and queue there or something, or start a line there.
I was curious. I came across something earlier. I'm sure people are familiar with the roles and profiles, and I saw a combination of using Hiera with roles and profiles to basically use the different upstream modules, as you said, like Spotify Apache versus, Puppet Labs Apache. What do you think about that, and how would it compare or contrast?
Yeah, I mean, we like the the roles and profiles pattern. I think it makes a lot of sense. I mean, as we're moving to putting node classification in Hiera, we would basically be embedding the role classes in Hiera. I mean, all the data about the role would exist there. And that could, of course, include profile classes. But the difference between, Puppet Labs Apache and Spotify Apache, that's, at the moment, the blocker is that you can't have both installed at the same time. They're both called Apache, so you can't have both modules.
Hey, you mentioned that you're deploying through Puppet and that the devs also work on their own modules. And so when you deploy, are the devs version pinning your debs in their modules for you deploying your application, or are you doing that through Hiera, or are you through ensure latest?
It's a bit different in different systems. Some of them use just ensure installed and use other methods to upgrade. It varies. I mean, in some of them, it's just SSH for loops to basically to do the deployments of a new upgrade to a new version, basically. In some of them, they ensure a specific version using Puppet, and use that to do upgrades. In others, they just do an ensure latest, and when they release a new stable version of their package, that means they're deploying it, basically. But we also have, different requirements for that in different backend systems. On some of them, they need to do a lot of caching. Like, for example, I mentioned the search system that has like these indexes on disk. If you restart them, they need to read in a lot of that index again. So when you're doing a rollout of a new version, you have to do it very slowly across your nodes, and preferably even send like less traffic to the nodes that have been recently restarted, and that sort of stuff. So there's different requirements for the rollouts and deployments in different services, and that can sometimes make it a little bit tricky to just like pin a version in the Puppet manifest.
So one of the main reasons we've run into the same thing about switching out the Puppet modules is that everyone uses a different version and exposes different define types. So whenever you want to switch something out, you need to switch everything out, and you can't always use a third-party module because it has other dependencies that conflict with your own modules. Have you ever given any thought if it would be at all possible to standardize some kind of interface around the module so you can actually say, I require a module that manages Apache instead of going, I require the Puppet Labs Apache module?
Yeah, I've definitely given it some thought. I've filed some bugs about those features. I think it would be good to have a kind of, provides keyword in the module files or something like that. So one module could provide the API of some other module and like provide and extend it and that sort of stuff, or have a bit more flexible dependencies in the Puppet module format. But unfortunately, that's not supported by the Puppet module tool that well at the moment, and we didn't want to implement like our entirely own tooling for this that uses like an entirely different format and so on. we wanted to reuse as much as possible from the upstream tooling. Any more questions? Otherwise, I'll be available afterwards.